Hi. So in this question we have a rotor disc, which is basically the thing that you mount the wheel on. So the drive shaft from the engine makes this disc spin so that the wheels can spin. That driving force has 200 newtons in this problem here. And there's also a frictional torque acting in the opposite direction, slowing us down. This is the frictional torque from the bearings. It has the same radius as the driving force, but it's acting in the opposite direction. So the first thing we're going to do is we're going to find the moment of inertia of this solid disk. So we know that the inertia of a disk is equal to half mr squared. Now we have the radius, but we don't have the mass. This is similar to the example number 1. We need to find the mass using m equals rho v. And we need to find the volume by finding the volume of this solid disk. Now the volume of this solid disk, I'll put it here, V equals pi r squared h. So it's pi. The radius is 150 millimeters. So 150 divided by 1000 to change it to meters, and square the whole thing like so. Multiply by the height. In this case, the height will be the thickness, which is 25 divided by 1000. Now, this gives you a volume of 1.76 times 10 to the minus 3 meters cubed. Now, let's plug this value back into our m equals rho v equation. The material is carbon ceramic. It has density of 2450 multiplied by 1.76 times 10 to the minus 3, this value we just found. That gives you a mass of 4.32 kilograms. Taking this mass and plugging it into our inertia equation, half 4.32 multiplied by 150, again convert to meters by dividing by 1000, is r squared, so the whole thing is squared. This gives us an inertia of 0.04 kilogram meter squared. Now, after this, we can go ahead and start solving the problem, because we knew at some point we needed the inertia. Now, part I simply says, derive an equation of motion that describes the system. Since this object is rotating, we have to use the rotational equation of motion, which is the sum of all the torques in your system is equal to I, the inertia, multiplied by the angular acceleration. Now, torques. We have two torques in our system. We have the driving torque, F, call it F1, multiplied by the radius, that's the first torque, minus the second force, which is the force due to the friction in the bearings, multiplied by the radius, is equal to I alpha. Now, we have F1, it's 2000, multiplied by R, the radius, which is 150 divided by 1000 is 0.15. Let's start writing it like this. Minus the second force, which is 500, multiplied by the same radius. They both act at the same radius, equals I 0.04 alpha. Simplifying this equation gives you 300 minus 75 equals 0.04 alpha. Final simplification, 225 equals 0.04 alpha. That's an equation that describes the motion of the system. Now, the second part wants us to find alpha. So we take this equation here, we rearrange it, so it becomes alpha is equal to 225, all divided by 0.04. that gives us an angular acceleration of 5625 radian per second. Now, third part asks us to find the angular speed after 10 seconds. In order to do this, we're going to use constant acceleration formula. We know this because the acceleration is constant. We found it in the last question. It's one number. So the equation we're going to use is v equals u plus at, but in the rotational terms, equals, the initial speed is 0, so it started from rest, plus alpha 5625, all multiplied by the time taken, which is 10. You can clearly see it becomes 56250 radian per second. Go back to this here, change it to radian per second squared. Don't forget alpha is radian per second squared in part 2. Now, IV. Last part of the question asks for the number of revolutions made in 10 seconds. So we can find the theta first, the total angle, then divide by 2 pi to find the number of revolutions. Omega naught t plus half a t squared equals the initial speed is 0, 0 multiplied by 10, let's substitute everything, plus half, alpha in this case is 5625, all multiplied by t squared, which is 10 squared. This gives you a theta value of 281,250. 250 radians, that's the total angle. To find the number of revolutions, number of revs you've made equals this angle divided by 2 pi. Once you divide the angle by 2 pi, you get 44762.3 revs made during the 10 seconds.